we are going to talk about the set of real numbers. It is the set obtained from the union of the set of rational numbers and the set of irrational numbers. It is denoted by R. You have to note that Q intersected by Q dash equals phi. So the real number is the union between the rational and the irrational numbers, and all other sets is subset from the real number. Alright. If A and B are 2 points on the straight line, which is the number line, the set of real number is an ordered set. The properties of order: if x and y are two numbers represented by the 2 points A and B respectively on the number line, then if x is smaller than y, it means that A comes before B. But if x greater than y, it means that A follows B. If x equals y, it means A coincides B. If x is a real number represented by the point A on the number line and O is the origin point which represents the number 0, then x greater than 0, x is positive real number if A is on the origin on the right of O, which is 0. X is smaller than 0, x is a negative real number if A is on the left of O, which is the 0, the origin point. X equals 0 if A coincides with O. According to this way, all real numbers which are represented by points on the right side of the origin O are greater than 0, and they are called the positive real numbers, and they are denoted by R. R positive equals x where x belongs to R and x greater than 0, but R negative equals x where x belongs to R and x is smaller than 0. You have to note that R positive intersected R negative equals phi, and R equals R positive union 0 union R negative. Let's take an example. Example 1. Write 3 irrational numbers included between the two numbers 11 and 12. As we know that the irrational number is a number which is not perfect to square, not perfect to cube. So to get the irrational number, we will get or find the answer of 11 power 2, 11 power 2, and 12 power 2. As we know that the irrational number lies between the two rational numbers, two integers, which 11 and 12. So we will get the square of the two numbers or the cube of the two numbers and find any square root or any cube root between these two square or cube numbers. So we'll get the square of 11 and the square of 12. The square of 11 equals 121 and the square of 12 equals 144. So we can find any square root of the number between 121 and 144. We have 125, 126, 130. All of these numbers between 121 and 144 are not perfect to square. So we can find any three rational number between these two square root of these two numbers. Example 2. Find the solution set and real number for each of the following equations. The first one, 3x power 2 minus 125 equals 221. As you know, when we are solving the equation, we keep x on the side alone and move all or transfer all other operations and number to the other side. So to transfer to the other side, we use the inverse operation. We have 3 x power 2. The operation between 3 and x is multiplication. 3 times x power 2 plus 125. We have a lot of operations: multiply, power, and addition. We'll start in the equation by addition or subtraction, after that multiplication or division. The last one is the power or root. So we will use the inverse operation of the addition, which is subtraction. So we'll subtract 125 from both sides. So we will get 3x power 2 equals 221 minus 125, which is 96. After that, we will use the inverse operation of multiplication, which is division. So we'll divide both sides by 3. Now we will use the inverse operation of the power, which is root. So x equals positive or negative square root of 32. Square root of 32 is not a rational number. So square root of 32 isn't a rational number. It belongs to irrational number. And also we know that the irrational number is subset from the real number. So square root of 32 belongs to real numbers. So the solution set equals positive or negative square root of 32. The second one, 6 x power 3 minus 8 equals 28. I'll give you 10 seconds to solve it. Okay, we'll start with which operation? 1 over 6 or power or minus 8? Exactly, we'll start with the inverse operation with the subtraction, which is addition. So we will add 8 to both sides. We'll get 36. Now, by which one will we start? 1 over 6 or power 3? Exactly, we'll use the inverse operation of the division. 1 over 6 or multiply 1 over 6 multiplication, so we'll use the division. We will divide both sides by 1 over 6 or multiply both sides by 6, so we'll get 216. Now we have the last operation, which is power. We'll use the inverse operation of the power, which is root, cube root, so we will get 6. Now 6 belongs to real number. It's a rational number, and as we know that the rational number is subset from R, so 6 also subset from belongs to R, so the solution set equals 6. The last one, 2x power 2 plus 6 equals 4. We will subtract 6 from both sides. After that, we will divide both sides by 2. We'll get -1. We'll use the inverse operation of the power, which is square root, but we can't find any number when multiplied by itself 2 times we get -1. We can find a negative number under the square root, so the solution set in this case is 5.